Support for Central Florida Public Media comes from the University of Central Florida, offering their Master of Science in Data Analytics program designed to enhance skills in data analysis and machine learning. The new Artificial Intelligence track offers specialized courses to deepen understanding of AI technologies and their applications. More at ce.ucf.edu/data.
A spacecraft that touched our sun and ghost riders in the sky. You're listening to Are We There Yet?, the radio show exploring space exploration. Hi, I'm Brendan Byrne. How do you study our sun when it's incredibly hot? NASA scientists figured out a way, and they're doing just that with the Parker Solar Probe. Equipped with an advanced heat shield and cooling systems, the spacecraft whizzed past the surface within 3.8 million miles, the closest any human-made object has gotten to the sun. We'll speak with NASA's Alex Young about the spacecraft and the data it gathered that could help scientists answer questions about our star, the formation of us and other stars in our galaxy. Then, a new space company is launching a lunar lander this month. Firefly Aerospace's moon mission is part of NASA's commercial lunar payload service to deliver payloads to the moon and conduct science on its surface. We'll speak with Firefly's Kevin Schultes about the company's lunar lander. That's ahead on Are We There Yet? Our sun, a hot yellow dwarf star that's about 4.5 billion years old, plays a crucial role in space weather and life here on Earth. But to study our sun more closely, a spacecraft must withstand extreme temperatures. Flying 3.8 million miles away from the sun's surface, the Parker Solar Probe whizzed by our star closer than any other human-made object and survived. Equipped with an advanced heat shield and radiator system, the probe broke its own record for closest flyby to the sun right before the end of last year, on December 24th. But why is studying the sun and the space weather it influences vital to our understanding of life here on our planet? Could data from our sun lead to answers about how life formed in our solar system and beyond? We're here to answer those questions and talk about Parker Solar Probe's success is Alex Young, the Associate Director for Science Communication and Heliophysics at NASA's Goddard Space Flight Center. Alex, welcome back to the show.
Thanks for having me.
The last time we spoke was before Parker Probe launched, 2018. Since then, what has it been up to?
It's been incredibly successful, since the launch, and even in the first couple of years, it started making amazing discoveries. Its beginning mission started actually with flying by Venus, because Venus is what we've been using to slow it down in order to get it closer and closer to the sun. And each time it passes by Venus, it's done this 7 times. It gets a little bit closer. So it has passed through the sun's corona. This is the outer atmosphere. And this is one of the regions that is most important for us to understand, in particular, something we call space weather, which can impact us directly here on Earth. And Parker has made some amazing discoveries in understanding what is driving that space weather, and also in particular, what is driving what we call the solar wind, which is this flow of solar material that's coming off the sun, occasionally has these bursts, which when they reach Earth can in fact create aurora, but also have very difficult impacts and disturbances on our ability to communicate and some of the other technology that we depend on daily.
The corona, that outer portion of the sun, is much hotter than the surface, right? Are we any closer to understanding why that's the case?
We are, and the great part about it is the solar wind and where it's coming from, what's accelerating, is part of this bigger question of what is heating the corona. Because it turns out that what is happening is something is putting energy into the corona, and that is causing the corona to expand and flow away and even accelerate. So we have made some major steps forward in understanding that, because we have a better understanding of where the solar wind is coming from and what is driving it. It's a really, really interesting and important problem, because it not only applies to our sun, but other stars in the universe. It's a weird thing where I think we're all very used to the idea that if you're standing next to a fire, like a campfire or something, and you walk away from it, it's going to get cooler. But the weird thing about the sun is that as you go from the surface out, the opposite happens. And as you mentioned, the temperature gets incredibly hot. The surface of the sun, the visible part we call a photosphere, is somewhere around 10,000 degrees Fahrenheit. But by the time you get to the corona, we're talking about millions of degrees Fahrenheit.
It's a crazy thing to think about, but it's also wild to think that you've got a spacecraft that's flying through that. I mean, how is the Parker probe able to get through those incredibly hot temperatures of the corona?
So one of the things that's really crazy is the corona itself, where it is emitting millions of degrees, is very, very thin. There are not a lot of particles there. So if I were to take a box, like a maybe 3 feet by 3 feet by 3 feet box, and I had corona in there would only be literally a handful of particles bouncing around, but they're bouncing around super fast. And that bouncing around, the speed they bounce around, is what we call temperature. And that's the same thing here on Earth. The air, as it's moving around, the faster it moves, the higher the temperature. But the difference is that here on Earth, we have almost an uncountable number of molecules that are bouncing around in our air. What that means is the way in which temperature is transferred is heat. Heat is this energy of motion. And so when you are in the air here on Earth, that heat is transferred to your body by all those little molecules bouncing off your skin. So if you put your hand in a box of corona, there are only a couple of particles which are not going to transfer that energy to you. So you wouldn't feel anything. So that's actually not what the Parker Solar Probe is feeling. What is experiencing, the incredible temperatures that it's experiencing, actually come from the sun itself, the light from the sun. It is so incredibly bright, and it's heating it up to potentially thousands, when it's close to the sun, many thousands of degrees Fahrenheit, which is so what the spacecraft has is a carbon composite fiber heat shield in front of the spacecraft. And that heat shield is wide enough that all of the instruments, save for one, are behind it in the shadow of the heat shield. And the heat shield also is very, very white, as white as we can possibly get it, which is also reflecting light off of it. And so that front heat shield, which is experiencing upwards of 2,500 or more degrees Fahrenheit, it's a nice, cozy, slightly warm, maybe 85 degrees behind that heat shield. I will add that there is also one other thing that's helping to keep it cool back there. The engineers have developed a very specialized type of radiator. So that radiator is also radiating heat out the back. And the crazy thing about that is that radiator is only using a gallon of distilled water.
That is fascinating. Engineering is incredible.
It really is. I mean, it is a marvel. And, we've actually been developing this mission for almost 60 years. It was first conceived of at the beginning of the space age in 1958.
Wow. And so it's finally gotten off the ground. It's made this historic closest approach to a star than ever before. But there was still a little bit of uncertainty during this close approach, right, Alex?
Absolutely. Yeah, so when it makes its closest approach, we have a period when we can't communicate with it. And so the people, the mission scientists and all of the scientists and engineers involved with it are literally on pins and needles, and they are waiting for 2 parts communication times. The first one is just a very basic, what we call a beacon back to Earth that says, everything's go. I made it. The spacecraft says I made it. And so that actually happened. So the flyby was around 6 a.m. Eastern time on December 24th. And then on December 26th, the spacecraft is far enough away that it's able to send a very, very basic signal that says, okay, I made it through. But then they have to wait a little bit longer to get the signal that gives it more detail and says things like, okay, I made it, but also all the instruments were on, we recorded all the data we wanted, and everything went, spectacularly well. And fortunately, that came on January 1st we received a stronger signal that provided all that information.
This vehicle, you said it's slowing down as it goes around Venus during this orbit. Is it going to continue to get closer and closer to the sun, or will Parker remain in this particular orbit for a while?
It will remain in this orbit. Yeah. So it's made its last flyby Venus. It had 7 flybys. The last one was November 24th. And so that's the last time it made a flyby, which is slowing it down. So now on its future orbits, it will be at the same distance. We call that close approach perihelion, meaning close to the sun. That particular perihelion, the one that we did on December 24th, was number 22.
The probe is part of NASA's Living with a Star program to explore aspects of the Sun-Earth system that affect life in our society here. You mentioned Parker wants to help us understand space weather. Why do people like myself and our listeners need to worry about space weather if we're not a spacecraft or an astronaut?
One of the things that people may sort of be on their mind is a lot of people may remember that aurora was seen very far south, even in Florida, in May, which is just unheard of. Well, what is causing the aurora are huge explosions that happen on the sun of material, billions of tons of material and magnetic field that are traveling away from the sun at many millions of miles an hour. And that stuff rides on top of the solar wind and basically is kind of enhancing the solar wind. When that material and magnetic field gets to Earth, it interacts with Earth's magnetic field, causing these huge electrical disturbances. And those electrical disturbances filter down into the upper atmosphere and excite oxygen and nitrogen, which those glow in particular colors and give us the aurora. The stronger that activity, the farther south you can see aurora. That activity is actually following a cycle on the sun. A cycle is roughly 11 years from low to high, back down to low. And right now, we are at the peak of that activity, what we call solar maximum. That activity is always around at some level. It is always impacting the upper atmosphere to some degree, which impacts communications. It disrupts certain radio frequencies, especially ones that are important for emergency services and the military. When it's closer to its stronger side, can damage satellites. It's dangerous to astronauts. And in the most extreme case, it can even disrupt power grids. But that space weather, because it is around all the time, even during low activity times, and is especially impacting communications, that's a really critical thing because those radio frequencies are one of the areas, as I mentioned, are first responders and emergency services. So if space weather happens during a hurricane or a tornado or some sort of weather related event, that can disrupt the ability of those particular services to communicate. That is one of the main reasons why we really want to understand it and be able to ultimately predict it, much like we predict weather here on Earth. Our field, which we call heliophysics, studying the sun and how it interacts with planets and atmospheres. And one of the things we've actually learned recently is that part of the atmosphere that connects directly to the sun and impacts our communications, it is in fact impacted by weather below. So things like hurricanes and even volcanoes erupting send energy upwards. And so we've actually found this crazy connection between terrestrial weather and space weather.
Finally, Alex, this is the first time a spacecraft like this is getting as close to the sun than ever before. Our sun is a star. Can the data and the lessons learned from the Parker Solar Probe be extrapolated to other star systems? What we learn from here can tell us about stars outside of our solar system.
Absolutely. Absolutely. That's one of the things that's exciting about being able to take this kind of data is because our sun is so close, we are able to study a star up close and personal. So our sun is like a laboratory, and we do extrapolate that data for all the other stars in the universe. We've discovered thousands of exoplanets, basically solar systems outside of our own. And one of the questions is, how does their star interact with those planets? What impact does that have on those planets' ability to support life or even have life form?
We've been speaking with Alex Young, the Associate Director for Science Communications in the Heliophysics Science Division at NASA's Goddard Space Flight Center. Alex, thanks so much for chatting with us.
Thanks for having me.
Still to come, Ghost Riders and the future of the lunar economy. That's ahead on Are We There Yet?
Support for Central Florida Public Media comes from the University of Central Florida, offering their Master of Science and Data Analytics program designed to enhance skills in data analysis and machine learning. The new Artificial Intelligence track offers specialized courses to deepen understanding of AI technologies and their applications. More at ce.ucf.edu/data.
You're listening to Are We There Yet? I'm Brendan Byrne. The moon is full of untapped knowledge, and NASA and partners like Firefly Aerospace are trying to get science equipment to the moon's surface to better understand its makeup. Firefly Aerospace's Blue Ghost Mission 1 is targeting an early liftoff on January 15th. It will take 45 days for the Blue Ghost Lunar Lander to get to the moon with 10 payloads on board. These payloads will help study rock samples, space weather, and the moon's surface. But this mission is just one of 3 moon missions from Firefly. Following the upcoming launch, new landers will journey to the lunar surface again in 2026 and 2028. Here to talk more about the Blue Ghost Lunar Lander and its upcoming missions is Kevin Schultes, Futures System Architect at Firefly Aerospace. Kevin, welcome to the show.
I'm glad to be here.
So, Kevin, Firefly is gearing up for a very exciting mission targeting a launch to the moon this month. But before we get into that, just could you briefly introduce us to the company Firefly Aerospace for those of us who may not be as familiar?
Firefly Aerospace is part of what is often known as a new space company. We have our origins in 2017, where we started off chasing after launch vehicle capabilities and have been growing our product line for our Alpha launch vehicle and our MLV launch vehicle. But along the way, we also made some big inroads with NASA and took on lunar landers. So the company that we have today is spanning sort of the regime of launch, landing, and orbiting, where we're trying to be the end-to-end transportation company for aerospace.
A founding in 2017, now in 2025, targeting the moon. That's quite quick and quite ambitious. Tell me a bit about what's gotten you to this point that has Firefly confident that this mission will be a success.
One of the things that makes us confident and that we lean on really hard is kind of inherent to the new space culture. And it's a strong bias towards action, strong bias towards rapid iteration and testing, and very flat organizations with extreme ownership over the products and the engineering. Engineers and even interns can come in and on day one be putting their hands on hardware and making a difference on a vehicle that's going to be going into space later that year. That kind of ownership is uncommon in this industry, and it creates a very short, very rapid feedback cycle on learning how things work in real world versus analysis, while still grounding that to our analysis. So overall, the team here has an incredible amount of exposure and experience on hardware and systems that's simply unachievable at other companies and is hard to come by so early in a career for most of the employees and engineers at this company.
Gavin, let's talk about this upcoming mission, this first lunar mission for Firefly Aerospace. First of all, what is it called? Because it's got a great name.
Our first mission is called Ghost Riders in the Sky.
And what's the purpose of this mission?
We are part of the Commercial Lunar Payload Services, is a contracting mechanism from NASA that we kind of colloquially refer to as CLIPS. And the aim of that is to help jumpstart a lunar economy, help create an environment in which there are robust commercial services that can support non-nation state interests in going to the moon, taking payloads to the moon. And NASA is taking the risk and leaning forward on the commercial aspect of the program by funding companies like ours to take their payloads to the moon on a commercial program. And what that means is that our lander is, it's ours. We can manifest the payloads that we want on it. We can put commercial payloads on it, provided that we also take NASA's payloads with us. So our main goal here is to demonstrate the ability to jumpstart that economy and show that there are, in fact, commercial providers that can execute these kinds of missions. Now, in terms of the mission specifically, for this first mission, the payloads that we're taking with us have a wonderful diversity scientific exploration. There are investigations into the material properties of the surface. There are investigations into the RF spectrum on the surface, all sorts of EM experiments. There are even updated versions of the laser rangefinder experiments from the Apollo program, as well as radiation sensing and sensing for fine particles and material properties interactions.
And how's it getting there? Can you walk me through from launch to landing how this is going to work?
So the Blue Ghost Lander for Mission 1 will be launching on top of a Falcon 9 launch vehicle out of Florida. We will launch it into a trajectory that approximates a translunar injection for the savvy listeners out there, but it's a little bit different in that we kind of point our lander at the moon, but just a little bit off. And by doing that, we end up in an orbit around the Earth, and we orbit the Earth a couple of times. And we actually use the pull of the moon's gravity to readjust our orbit into position to then go and inject into a lunar orbit. And this saves us a lot of efficiency in propellant and things of that nature. But it means that we take a little bit longer than other approaches. So other approaches might get there in a week. We get there in about a month. And once we get into lunar orbit, commission in lunar orbit for communications back to Earth, and then we do this big landing burn, we come and land down on Mare Crisium. And something that's really unique about our approach is that whole landing process, we rely on vision navigation. So technology has improved tremendously over the last few decades in terms of kinds of local navigation capabilities. So instead of the pilot in the loop kind of approach that we're kind of familiar with from Apollo days, what we have is a more intelligent software system on board instead of something like a pilot that's navigating visually just like a pilot would, looking at the surface features of the moon and using that to determine specific location and velocity and attitude. So it's called vision navigation, and it really heavily tests a part of our whole system. And that's kind of unique in how we land. I think other systems rely on other kinds of instrumentation, but this is a really fantastic demonstration of the capabilities that have really come online in the last decade in terms of computational power and intelligence and autonomy.
How big is Blue Ghost? What does it compare to?
It's a little bit under 2 meters tall. So it's going to be approximately 6 feet and change. Standing next to it, it's more comparable to the size of a Jeep. It's a large vehicle in that respect. The total mass is about a metric ton and a half. It kind of looks like, I don't know if you've ever had a Rolo kind of a candy, but
Yes, that's exactly what it looks like.
Yeah, it kind of has that semi-conical shape, but with like a pair of legs and the golden wrapping on it to boot. So that kind of gives you a good visual feel of it.
I'm looking at an image of it now, and it perfectly describes it as a Rolo. It's just a 6 foot tall Rolo, which is awesome. This first mission is launching this month. We know missions to the moon are quite difficult and challenging. What do you define success from this first mission?
Success can be measured in so many different ways. I mean, the ideal scenario, of course, is that we touch down softly and we have a full 2-week mission during the lunar daylight period, and we return payload data on every single one of the payloads that we take with us. That is a full scope ideal outcome for the scenario. Now, things are incredibly difficult in terms of deep space missions in general, planetary missions, especially so, landing on the moon especially so. There are measures of success too, where every step of the way we're building success for the future of Blue Ghost, for the future of the CLIPS program, and for the future of the lunar economy. So as soon as we get off the launch vehicle, we're already buying down risk on all 3 of those branches of the future.
There's obviously some confidence in this plan as you've got another mission, Blue Ghost 2, scheduled to launch in 2026. And then recently, NASA awarding Firefly $179 million to deliver 6 experiments to the lunar surface on its 3rd lunar mission. Tell me a bit about that NASA mission. What's really exciting about that one?
That one's also on the near side. For your eagle-eyed listeners, if you take a look at the moon at night, our landing position will be the northwest sort of edge of the moon. The 2 great oceans of Mare meet. I think Mare Imbrium and Oceanus Procellarum. They meet together, these ancient lava oceans. And where they meet are a set of ancient volcanoes that have very unique surface properties that scientists are interested in studying. And on one of those volcanoes is an impact site where a crater was formed that broke through many layers of deposition and regolith and scattered this massive boulder field around the volcano. NASA wants us to land essentially right in the middle of that boulder field, surrounded by all sorts of hazards, and take a rover with us that will get off and then go and explore the boulder field and the surrounding area and better understand both the interior and the exterior of the moon from this natural sampling of the surface of the moon. The more common touchstone for folks often are the Mars missions. And in the Mars missions, the lander will touch down, or you'll get the incredible sky crane maneuver. You'll get a rover on the surface. And then the engineers back on Earth will spend, several weeks commissioning that rover, getting it ready to go execute its mission. And then that rover will go and drive out for, however long it can survive, in the case of like Curiosity, for example, almost a decade or over a decade, I think, at this point. And this incredible long-term, methodical, careful progression. We get 2 weeks of life on the lunar surface. A full lunar day lasts 2 weeks. A full lunar night lasts 2 weeks. And the difference between the two are plus 250 degrees in sunlight, minus 250 degrees at night. Right now, surviving the lunar night is not a technological option that we've invested in the CLIPS program just yet. I think it'll be something that we do in the future. So we get a grand total of 2 weeks to do this rover mission, which means we are up against the clock the moment we touch down. The moment we touch down, we have to get the rover off the lander, commissioned, and running its mission as quickly as possible, because you get 2 weeks to make it all worth it, to get as much science in before the sun sets and its end of mission. That's an incredible challenge, and it's pretty incredible even in scope of the incredible work that's been done on Mars, for example, just in terms of how much we have to accomplish and how ready and prepared we have to be the moment that we land. It's also incredibly flattering that NASA has entrusted us to be the company that can do that.
Kevin, finally, I'm going to ask you a kind of a future question. You may not have the answer to this right away, but you mentioned starting a lunar economy, and we know CLIPS is part of that and Firefly is part of that. You're launching in 2025, plans for 2026, plans for 2028. How frequently do you see missions like Blue Ghost flying in the next 10 years? Is this going to be something that me being here along the Space Coast, looking out my window and seeing a new shipment going to the moon every month? Is that where we're going to be getting at soon?
That depends on a few things. I think in terms of the CLIPS kinds of missions, I suspect that we're probably going to get into a pretty strong cadence of probably about 2 missions a year for the foreseeable future in terms of that scale of mission. The way I like to think of the scale of lunar missions that are being talked about and planned right now are sort of exploratory missions, cargo missions, and then sort of the big infrastructure missions. So you can imagine the big infrastructure missions being, landing surface habitats for Artemis astronauts, cargo missions being delivering supplies to those surface locations, and then the exploration missions, which are more like what the CLIPS program represents, which are smaller, purpose-developed explorations of specific locations on the moon. And the moon is as small as it is compared to the Earth, it is such a vast and incredible place that I don't think we're going to run out of interesting places to go anytime soon. And a good pace for that is probably about 2 missions a year. I would love to see that be a little bit higher, but I kind of anticipate that that's what it'll be. And then when we get to the point where we are supporting active, permanent presence on the lunar surface, be it robotic presence that survives the night or human presence, then I think you're going to see a launch cadence that's probably measured in the high single digits to low double digits of launches per year in terms of support for efforts going to the moon directly. That's my initial prediction here, 2025, but I also know experientially that you cannot predict the future, so we'll see how it plays out. But I think if we saw that would be an incredible sign of success.
That was Kevin Schultes, the future system architect at Firefly Aerospace. That's going to do it for this week's show. If you're not already, be sure to subscribe to the show's podcast feed so you never miss an episode. Do that on Apple Podcasts, Spotify, the NPR app, YouTube, or really wherever you get your podcasts. Stay connected with the show. Follow us on social media. Find us on Instagram at Facebook. Our handle is AWTY Space. If you got an idea for a future episode of this show, or you want to join us as a guest, reach out. Our email is arewethereyet@cfpublic.org. More space coverage online. Visit cfpublic.org/space. Are We There Yet is a production of Central Florida Public Media. Our producer is Marion Summerall. Editorial guidance from LaToya Dennis. Support for Are We There Yet comes from our listeners. Until next week, I'm Brendan Byrne. Thanks for listening.